Chapter 14, From Randomness to Probability. The objectives that you should keep in mind is the law of large numbers concept, solving problems using the addition rule, multiplication rule, and conditional probability, determining if two events are independent, and creating probability distributions by using simulation techniques. What you should have learned in this chapter is dealing with random phenomena, the law of large numbers, the non-existent law of averages, modeling probability, personal probability, the first three rules for working with probability, and formal probability. Here are the videos that you may watch after reading the book. So, dealing with random phenomena. For example, a random phenomena is a stoplight, and every time you arrive at the light, it is always random. Some things to know about random phenomena is each time we observe a random phenomenon, it is called a trial. The value of the random phenomenon is called a trial's outcome. When we combine outcomes, the result is an event, and the collection of all possible outcomes are called sample spaces. The law of large numbers is the principle that can give us a guarantee that the frequency of an event will not move from one value to another. It can simplify things if we can assume events are independent, which basically means that outcomes are not affected by other outcomes. This also states that as the number of independent trials increases, the long-run relative frequency of repeated events gets closer and closer to a single value. Because the law of large numbers guarantees that relative frequencies settle down in the long run, we can call it probability of events. The empirical probability is based on repeatedly observing the event's outcome. The non-existent law of averages. So the law of large numbers is often misunderstood because the idea of the long run is hard to grasp. Many people believe that an outcome of a random event that hasn't occurred in many trials is due to occur. This means that when you toss a coin 10 times and those 10 times are all heads, many people will think that the 11th time has to be a tails because it just hasn't happened yet. It does not work this way because every coin toss is its own independent event. What is wrong about this law is that it does not state anything about the short run behavior, which is like tossing it 10 times. But the law of large numbers states the long run probability, which is if you were to toss the coin 1,000,000 times, you will get roughly 50% tails and 50% heads. Modeling probability. French mathematicians developed a model of theoretical probability. And this is how it looks like. So to find the probability of A, you get the number of outcomes in A over the number of possible outcomes. And something to keep in mind is that random events are not always equally likely. For example, winning the lottery is very small even though it is random. Personal probability. Personal probability is something that we use personally. The example that the book used was the probability of getting an A in statistics. So your personal assessment of your chances of getting an A expresses your uncertainty about the outcome. This does not use math, it uses our own personal assessment based off of experiences, which makes it not consistent. The first three rules for working with probability is to make a picture. And the most common picture we use is a Venn diagram. Formal probability is basically the opposite to personal probability is when we actually use math. So the phrase 50-50 basically just means equally likely. If the probability is 0, the event can never occur, and if the probability is 1, it always occurs. When probability only deals with one possible outcome, it is not random. So here's the first rule, which is the complement rule. The set of outcomes that are not in event A is called the complement of A. And that rule is the probability of an event occurring is 1 minus the probability that it does not occur. The next rule is for two disjoint events, A and B, the probability that the one or the other occurs is the sum of the probabilities of the two events, provided that A and B is disjoint. For two independent events A and B, the probability that both A and B occur is the product of the two events, provided that A and B are independent. So here's the just checking on page 327 and 333. What can go wrong? So you should be aware of probabilities that don't add up to 1. All outcomes must add up to 1. They are all a percentage out of 100. Don't add probabilities of events if they are not disjoint. So events must be disjoint to use the addition rule, and the sum may be more than 1. Also, don't multiply probabilities of events if they are not independent. And another thing is, do not confuse disjoint and independent. Disjoint and independent are two opposite things, because if events are disjoint, that means that they are able to happen together and affect one another, and independent means that they cannot be affected by each other. And here's the homework.